Hello everyone, this is Mrs. Pickett and we're going to take notes over lesson 1-4 today. So make sure that you either have printed this out or you're writing this in your notebook. I'll put the heading here for you. So this is lesson 1-4, we're going to talk about angles. So up to this point we've pretty much just talked about the basics of geometry, points, lines, and planes, and then we focused on segments because they are a part or like a section of a line. So now we're going to get into angles. So an angle is formed by two rays. So remember we talked about rays, they have a starting point and then they would go on in one direction. So an angle is formed by two rays. With your ray, you have a common endpoint, and that is called a vertex. So in this picture right here, B would be the vertex, okay? That is the beginning or the end. It's called an endpoint, but that's where the ray starts. So your two rays, all right, you have ray BA and ray BC. So rays are called the sides of an angle. So again, an angle is formed by two rays. They have a common endpoint, which is called the vertex, and then the rays are also called the sides of your angle. Okay. Now, when you are naming an angle, you're going to use 3 letters. Okay. You have to remember that the middle letter always represents the vertex. So B always has to be in the middle. So when we're naming a letter, you're going to use the angle symbol. Kind of looks like a less than sign. All right, and so this could be known as angle ABC, or you could go the other direction and call it angle CBA. But notice B is always in the middle. The vertex has to be the middle point no matter what. Now, if you only have one angle, so if you had a picture of what I've drawn here and there's just one specific angle, you can actually do a shortcut and you can name it by the vertex. So we could, since this is just one angle by itself, we could call it angle B. But now this one only works if there is only one angle in the picture. And most pictures are going to have multiple angles, so make sure you understand how to name it using the 3 letters. Okay? All right, so now we're going to get into, so that's what like the basic idea info behind angles. Now there are certain types of angles, so I'm going to scroll up here a little bit. And this should be pretty familiar. So the first type here is an acute angle. Okay, acute angles are all less than 90 degrees. Okay, so 90 degrees is a right angle, and we'll talk about that in a minute. But acute angles are less than 90. And so when we're looking at the angle, we're looking from side to side, the inside of it, okay? Then you also have obtuse angles. And obtuse angles are angles that are greater than 90 degrees. So again, if we look inside here, we can see that that angle is greater. And then you have right angles. And a right angle is equal to 90, so exactly. And notice that in order to signify a right angle, we have the little square right there that lets you know that it is right. And then the last type of angle is called a straight angle. Okay, so it looks like a line. A straight angle is a line, but remember we have 2 separate rays. So you have a ray going to the right, and then you also have a ray going to the left, okay? And so that angle is equal exactly to 180 degrees. All right, so let's jump down and do some examples together. So here's the picture under example 1, and we're going to do some things that we were just talking about to see how well you understood. So if you name the vertex of the angle, the vertex, remember that is the center where the 2 rays begin. That would be point K. That is the vertex. Remember when we name a point, it's just a capital letter. If we're going to name the sides, remember they are rays, so the symbol is an arrow. And then I have ray KL and ray KJ. Notice you always start with the vertex when you're naming them. 3 ways to name the angle. So you could just use the vertex since there's only one angle in the picture, so we could call it angle K. The next one, you could call it angle JKL, or you could call this angle LKJ. Those are the three ways to name this angle in example 1. If we were to classify this angle, so remember from side to side, that is going to be greater than 90 degrees, and so this would be an obtuse angle, okay? So what I would like to do on your own, you try to do example 2, and then tomorrow in class we will talk about example 2 together when I'm actually there with you, okay? So let's jump down here to the next part of notes here. This is going to be congruent angles. So if, and now looking at the picture over there, if I tell you that the measure of angle A, so that little M stands for measure, is equal to the measure of angle B, then the angles are congruent. So it's the same thing we were talking about when we were talking about segments. If the measures are equal, then the angles are congruent. And then if I wanted to talk about this, if we were talking about congruent angles, I would say angle A is congruent. Now, the congruent symbol is a little squiggly, and then the two equal sign, or like lines, to angle B. So notice, when we're talking about a measurement, you put the M in front of it for measure, and then we use an equal sign, okay, right here. If we're talking about the angles themselves, we would refer to them as being congruent, and we use a congruent symbol, okay? Let me go to the next page. So an angle bisector, now we've already talked about bisecting a little bit when we were talking about midpoint. So an angle bisector, this is a ray that divides an angle into two congruent angles, okay? If something is being bisected, it's breaking it up into two equal parts. So in this picture over here to the right that I'm showing you, we would actually say that ray BD, so I'm going to put an arrow up here. I'm going to highlight it. So this right here, that is your angle bisector. So it's dividing the large angle, okay? So let me just see. So we had this large angle ABC. Now when I draw in ray BD, now I've divided it up so I have two smaller angles. And those angles, it would be angle ABD, and it would be congruent to angle CBD, okay? Oops, let me change. So you have an angle here in blue. I called it ABD. You could have called it DBA. It means the same thing. And then you also have this smaller angle here in yellow, okay, CBD. So angle bisector is now divided up, and you have those two angles that are congruent. So they would have the same measurement. Okay, perpendicular lines. Those are two lines that intersect. Okay, so remember intersect. That means they cross each other. And when they intersect at a right angle. So if we look at the picture, whoops, let's do a different color. So you have line M and you have line L. And notice that when they intersect, you are getting a right angle, and we know that because of the little symbol here, the box that's drawn in to letting you know it's 90 degrees. Okay. Now the symbol for perpendicular, it looks like an upside down capital T here. Looks just like that. That's the symbol. So you don't always have to write out the word. You can use the symbol. And in the diagram to the right, what I was just talking about, we could say that line L is perpendicular to line M. All right. Perpendicular bisector. So let me move up here. When you have a perpendicular bisector, so bisect, it means it's cutting it in half. It can be a line, a segment, or a ray that is perpendicular. And you can use this symbol. I just wrote out the word so you could see it. To a segment at the midpoint. So if it is bisecting, and we talked about this earlier, in order to bisect, that means that it has to cross through the segment or the angle, wherever, at the midpoint. So in the diagram here that I'm showing you with the LM and PQ, we could say that segment LM is a perpendicular bisector to segment PQ, because LM is what's cutting through, okay? So the midpoint would be right here. Put a red dot on it, Okay, that would be the midpoint. That's where it's cutting through. Notice there are tick marks here. So when you have the tick marks, that lets you know that each segment is congruent to the other. Okay, so let's try one example together. We'll do example 3 together on the notes here. It says write another name for angle CBF. So if you go over here and look, so CBF is right there. So another name, you can reverse it and we can say angle FBC. Okay. If they want us to name the sides of angles EBD, so now we're looking at name the sides of angle EBD. So it's always good to be able to pick out and identify the angle. So a side, remember those are rays. So we have ray BE and we have ray BD. Those would make up the sides of that angle. Let's go to C. We're going to classify angle ABC. So again, if we look, so angle ABC, well, that makes a straight line, therefore that is a straight angle. In D, give an example of an obtuse angle. So a different way to ask the question. So now they're telling us obtuse, and so you have to find one that is an obtuse angle. So if you're looking, you could use EBD. That one is greater than 90 degrees. So we could say angle EBD. You could have called it DBE. That would work as well. Another one you could have said, just so you can see if you picked out a different picture here, or different angle, EBC is also an obtuse angle, or CBE, that would work. Two congruent angles, so we need two angles that are the same measurement. So just like when we do segments and we have tick marks, in angles you have arcs. So notice there is an arc right there and an arc right there. They're letting you know that this angle, so the first one here, I'm going to call that angle ABE. That one is congruent, or it has the same measurement, to angle CBF. Okay, and I knew that because of the arcs, that little curved piece in between. It's letting you know that those two angles are the same measurement. All right, and then the last question on this example says name a perpendicular bisector. So we need to know something that's cutting through at a right angle, and it's cutting through at the midpoint. So if you look, we have tick marks here and here. So that means those two have to be congruent. And then right here, you have this ray, and there is a right angle. So that means it's perpendicular, and it's cutting through at the midpoint. So for this one, a perpendicular bisector, we could call this ray BD. Ray BD is acting as a perpendicular bisector to line AC. All right. If you want to try example 4 on your own, go ahead. I'm going to jump over here. We got one more thing. Last thing I'm going to show you, and this is still part of lesson 1.4, is the angle addition postulate. We did segment addition. It is the same thing. We start with a large angle. When you divide it up, you now create two smaller angles. So we would have angle ABD here in green plus DBC in yellow. If you add those two smaller ones together, they have to equal the total. So if we're looking at this, I have angle ABD plus angle DBC, and it has to equal the total, or the large angle, which would be angle ABC. Okay? We're just going to do 3 examples here on this, and then we'll save the rest for class. So if we're looking at this picture, for number 1, it says if the measure of ABD, and again, I encourage you to label parts. So we know ABD is 48, and DBC is 78. Find the measure of ABC, so we're looking for the total. That means I want to add those two together. So basically you would do 48 plus 78, and that gives you 126 degrees. Okay? On number 2, Let me erase what we put here.